Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ong. In this tutorial video, we'll go through this 14 to 16 years old combined science chemistry curriculum. This is basically the triple sciences, 3 sciences combined into 1 subject, and as such the contents are a bit more diluted. This is the continuation of organic chemistry, particularly this is on the alkanes chemistry. Remember that we talked about in the previous lecture tutorials, the one ending with ANE is basically alkanes. These are CnH2n plus 2 general formula. So here we're going to be looking just specifically into more chemistry of alkanes. For the first bit, we got to know that the bonding in alkanes is just single covalent. So it's just CC and also CH there. And we know that CH is always true because hydrogen with 1 electrons in the outer shells, hydrogen only forms single covalent bonds. So hydrogen only forms single covalent bonds, but carbon with 4 electrons in the outer shell, then carbon will form 4 covalent bonds altogether. We also see here alkanes are saturated hydrocarbon. These are very popular definition which we'll talk about shortly. We're going to describe the properties of alkanes. Number 1, generally unreactive, except combustion. Combustion means burns in oxygen, so you burns in excess oxygen. And what do you get when you burn alkanes? Alkanes are hydrogen and carbon in the compounds only. That's called hydrocarbon. So when they burn in excess oxygen, CnH2n plus 2 with oxygen will just give you carbon dioxide, CO2. So that is one of the source of carbon dioxide in environmental chemistry, as carbon dioxide can cause global warming because it is a greenhouse gas. Environmental chemistry was covered in year 10 combined science chemistry. So alkanes contain single carbon-carbon covalent bond. Alkanes are saturated. Now what does saturated means? Saturated means only carbon-carbon single covalent bond. So that is the meaning of saturated, only carbon-carbon covalent bond in alkanes. Alkanes are generally unreactive. Why? Because you have strong covalent bonds. If you want to react them, you have to break strong carbon-carbon covalent bond, strong carbon-hydrogen covalent bond. But alkanes do undergo combustion reaction. As I said, if you have excess oxygen, then you will burn in excess oxygen. One thing we know is combustion is always exothermic. Combustion always releases heat energy to the surrounding. The definition of exothermic reaction was from year 10, energy changes. Year 10, energy changes topic. So this is energy changes in a chemical reaction. So when this reaction releases heat energy to the surroundings, so what will happen to the temperature of the surrounding? The surroundings will get hotter. So the temperature of surroundings would increase, temperature of surroundings get hotter. Those two are the definition of exothermic reaction. It releases heat energy to surrounding, temperature of surroundings get hotter, or it increases, that kind of stuff. Combustion of alkanes require oxygen as a reactant. You burn in excess oxygen and then you will release heat energy. But at the same time, complete combustion also form carbon dioxide. Carbon dioxide is this CO2, where carbon form 1, 2, 3, 4 covalent bonds. Oxygen form 2 covalent bonds. We go back to atomic structure. Carbon, 4 electrons in the outer shell. Therefore, you want to form 4 covalent bonds, but oxygen with 6 electrons in the outer shell, they just want to form 2 covalent bonds. So therefore, they want to share 2 electrons only to complete the outer shells. It all comes down to how many electrons do you need to complete the outer shell. Carbon need 4, so carbon will form 4 covalent bonds. As you could see from the diagram above, these are display formula, show all the atoms and all the bonds. Questions, however, love to ask you on dot and cross. Dot and cross is from year 9 covalent bonding vocabulary. The carbon with 4 electrons in the outer shell, they share 2 electrons with the oxygen. So I'm going to use 2 electrons, 2 of the dots from the oxygen. If I use 2 out of 6, because we never use the inner shell, we only use the outer shell electrons for bonding. We only use 2 out of 6. We still have 4 more on the oxygen, like that. But then this carbon still form another 2 covalent bond to the oxygen, so another 2 crosses, another 2 dots from the oxygen, and therefore I have 4 more on this oxygen as well. This is the complete dot and cross diagram. Around the carbon, 4 electrons, 1, 2, 3, and 4 in the outer shell, shares 2 electrons from the oxygen, share another 2 electrons from the oxygen. This carbon now has 8 electrons in the outer shell. This oxygen, 6 to begin with, 6 dots, share 2 electrons, just like the other oxygen on the right, therefore forming 2 covalent bonds on each oxygen. Carbon in the center form 4 covalent bond. We have water. This is H2O as part of your year 9 dot and cross vocabulary. We also know that oxygen forms single covalent bond to the hydrogen, single line there, single covalent bond to the hydrogen there, another single line there. Oxygen has 6 electrons in the outer shell. If I use 1 and 2, I'm still left with 4 more electrons on each oxygen. This is the correct dot and cross diagram for water, H2O. This is just balancing equation. C3H8 is alkane. How do I know it's alkane? Because 3 times 2 is 6, 6 plus 2 is 8, CnH2n plus 2, for n equal to 3. This is what you call propane. CnH2n tells you it's alkane. 3 carbon there tells you it's prop, so it's propane. With oxygen, you get carbon dioxide and water. If I show you how to balance the equation, C3H8 plus O2, we're going to get CO2 and H2O. The first thing that comes to mind is 3 carbon there. There is only 1 carbon in CO2. Cannot change the formula. Put 3 in front. 3 in front would mean 3 carbons, and then 3 times 2, which is 6 oxygen, because what you have is CO2, 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 then you have 3 carbons, 6 oxygen. H2O come from the hydrogen there, 8 hydrogen atoms. We have 2 hydrogen atoms, 1 and 2 in water, so we need 4 H2O, because 4 times H2O means you have 4 water molecules like this, and you could see that you have 8 hydrogen, because you read from left to right, 2, 4, 6, 8. You have 1, 2, 3, 4 oxygen. 4 plus 6 oxygen is 10 oxygen atoms. You have oxygen diatomic molecule. So 2 atoms bonded together by covalent bond. It's an element because it only contains 1 type of atoms. You have 10 oxygen atoms on the left. 10 oxygen atoms, not molecules. On the right, sorry. So you need 10 oxygen atoms on the left. You cannot change the formula of oxygen, which exists as diatomic molecule, to complete the outer shell. So 5 times 2, 5 of these will give you 10 oxygen atoms. That is how we balance the equation. Balancing equation is in year 9. Year 9 chemical equation has already taught you how to balance chemical equation. For the second one, incomplete combustion. Incomplete combustion was part of year 10 environmental chemistry. In the environmental chemistry section, we talk about the sources of pollution. So one of the pollutant included was carbon monoxide, the other one was carbon dioxide. Carbon dioxide comes from complete combustion of hydrocarbons. Carbon monoxide comes from incomplete combustion of hydrocarbon. When you don't have enough oxygen, you're going to get CO. Carbon dioxide is a greenhouse gas. So CO2 is a greenhouse gas. So a greenhouse gas can cause global warming. It can cause the whole world to become hotter. It can cause prolonged period of drought without water. It can kill crops, etc., etc. The next one is carbon monoxide with 1 oxygen only, whereas previously it was called carbon dioxide. Di refers to 2 oxygen on the carbon. This is carbon monoxide. The biggest danger of carbon monoxide is that it has a toxic effect. It's a toxic gas. It can definitely kill people because it is toxic there. In this next part, we're going to be talking about alkenes. Alkenes are that CnH2n, carbon-carbon double bonds within the structure. So show that or state that the bonding in alkenes, double carbon-carbon covalent bond, that is basically what that was. And then alkenes are unsaturated hydrocarbon. So new words here, saturated was carbon-carbon single bond. Unsaturated means carbon-carbon double bond here. Unsaturated hydrocarbon means carbon-carbon double bond. Hydrocarbon means they contains only hydrogen and also carbon atoms only. So in your compound, you only have carbon and hydrogen, but you have carbon-carbon double bond. You call it unsaturated hydrocarbon. We're going to manufacture alkenes and hydrogen by the cracking. So this process called cracking of large alkanes is basically large or long chain alkane. We're going to use high temperature and a catalyst. So catalyst will speed up the rate of reaction. This is from year 10, rate of reaction topic. We talk about catalyst, making the reaction go faster, but itself will remain chemically unchanged at the end of reaction. Describe the reasons. Look at the plural. Why do we want to crack large alkane molecules? Because we want to get short-chain alkene. Why are they valuable? Because they are valuable. Why is it important? Because they are valuable and it can make a lot of profit for big company, oil and gas company, of course, yeah? The next one, we're going to be looking at the test to distinguish between saturated. Saturated is carbon-carbon alkane, and then we have unsaturated, which is to do with carbon-carbon double bond alkene. We're going to react it with aqueous bromine. Not our first time in aqueous bromine. This is in year 10. Periodic table chemistry, where we talk about group 7. In group 7 chemistry, we know that bromine is colored. Bromine as a liquid is red-brown liquid. But then we also know that when you dissolve in water, that this color could change to become a bit lighter. So Br2 aqueous is definitely aqueous. It means dissolve in water. This one is more orange yellow. The color is a bit lighter, and that is what we are using here because we are using aqueous bromine. We are not talking about liquid bromine here. So orange yellow is our starting color, and it will decolorize in the presence of carbon-carbon double bond. That is what reacts with the aqueous bromine, not the alkane. We're going to do an addition reaction. So overall, this thing is called addition reaction. This is with the carbon-carbon double bond, and you only get one product in an addition reaction. So addition reaction, two things add together, you get one product out. Just to go through the actual contents, alkenes contain carbon-carbon double covalent bond. So very characteristic of alkenes. Alkenes are unsaturated. Unsaturated means contain carbon-carbon covalent bond. Unsaturated hydrocarbons means the compounds contain hydrogen and carbon atoms only, but you also have carbon-carbon double covalent bond because they also want the meaning of unsaturated. This term called cracking. So cracking basically produce short chain alkenes and also hydrogen gas. You need high temperature, so 450 degrees Celsius or 500 degrees Celsius, both are okay. This catalyst is very important. You need heat at very high temperature. You need a catalyst in order to do cracking. They love to ask you what are the conditions required for cracking. What is this process called that you need to, break long chain hydrocarbon into the short chain hydrocarbon. You call it cracking. In order to produce short-chain alkenes, you do a high temperature and you use a catalyst. What are the reasons in terms of plural there? Because short-chain alkane and alkenes are more useful. Because they are more useful, people find more use for them. They are more valuable and therefore bring more profit. As big corporations go, that is the main purpose, profits in industry. Okay? So in terms of the questions, what could they ask you? They could ask you to write equation number 1. So you got to follow the questions, how many multiple they want you to do. This is just examples. These are not something that you will memorize. These are just examples. For example, they say crack this thing. You get 3 products. You get one of these, and 3 of it. And this first product has 8 carbon alkane. This is CnH2n plus 2. So that one is alkane. You also produce a 3 carbon alkene. CnH2n there. So there is alkene there for the second one. And then the third one is also CnH2n plus CH2n. So the third one is also alkene there. So you got 2 alkenes here, CnH2n, CnH2n. But this is 2 carbon alkene. 2 carbon alkene is what you call ethene. It was in the syllabus. We mentioned about it in the previous lecture tutorial. So this alkene is called propene there. And of course, you could also produce hydrogen gas. This is another possibility. This is another possibility. So if they want you to produce hydrogen gas, you will produce hydrogen gas, H2, diatomic molecule. Hydrogen form a single covalent bond to complete the outer shell there. Alkanes only undergo combustion based on the previous part of the lecture where we talk about alkanes undergo combustion reactions because alkanes are typically unreactive due to very strong carbon-carbon single and carbon-hydrogen covalent bonds that you need to break. They are unreactive except in combustion where they could give you CO2 and H2O, complete combustion, carbon monoxide. If you have incomplete combustion, it's the same thing with alkenes. Alkenes can also undergo combustion. You can have complete combustion. Complete combustion will give you CO2 and also H2O. You could also get incomplete combustion. So incomplete combustion will give you carbon monoxide and also water. So carbon monoxide is toxic. Carbon dioxide is a greenhouse gas, can cause global warming. Do not get confused between the two. Alkenes can undergo addition. So what it does is carbon-carbon double bond, you can add Br, and what happened then is carbon-carbon double bond becomes single bond like this. Of course, carbon form 4 covalent bond. So, you still have 1, 2, 3, 4, 1, 2, 3, 4. But no more bromine, you get one product. When two things add together, you get one product. Addition reactions, when you have a simple molecule add onto the carbon-carbon double bond, forming only one product. As stated in the syllabus, you can only add across carbon-carbon double bond. You cannot do this onto carbon-carbon single bond. So if you have that, which is alkane, if you add it with aqueous bromine, which is orange-yellow in solution, so orange-yellow solution, you will not get any addition, so no reaction. If no reaction, what we say is not decolorized, because bromine is colored in solution. So when it forms this, so bromine water will get decolorized, or we say aqueous bromine turns colorless. Turns colorless means the color become decolorized, whereas in the case of alkanes, you get no addition because no carbon-carbon double bond. So therefore, no reaction, no addition reaction, therefore not decolorized there, it remain orange-yellow. Be very careful. We'll talk more about polymerization next time, but let's just finish off this particular chemistry. When we add Br onto the double bond, we're going to get this Br having added onto the double bond, so no more bromine, and therefore this thing will decolorize. This thing is orange-yellow, so orange-yellow solution get decolorized. Orange solution decolorizes, so it turns colorless, it becomes decolorized there. If you have propene, this is ethene just now, 2 carbon alkene, whereas this is propene, 3 carbon alkene, and this is E, so it's carbon-carbon double bond. This is carbon-carbon double bond alkene. If it's 2 carbons, we could see 3 carbon, 1, 2, 3, 4, 5, 6, C3H6, consistent with CnH2n, alkene general formula there. So what we have done is we have gotten bromine decolorized because the bromine add onto the double bond. Here, the bromine add onto the double bond, and now the 2 hydrogen there remains, and now you have added the Br and the Br. This is just drawing the product. As you can add, what you do is you add bromine and bromine. This is in aqueous Br2 molecule dissolved in water, and you add it across carbon-carbon double bond. This is called an addition product. Why is it an addition product? Because you get it from an addition reaction of a small molecule across carbon-carbon double bond, and you can do that because you have unsaturated hydrocarbons are basically alkenes. They are compounds containing only hydrogen and carbon, and they have got carbon-carbon double covalent bond there. So test for unsaturated hydrocarbon or test for unsaturation carbon-carbon double bond. Just add aqueous bromine. It will turn from orange-yellow to become colorless there. Test for every alkene is like that. With alkanes, you don't get any decolorization. It just stay orange-yellow because you cannot add onto carbon-carbon single bond there. So I'll stop there for these lecture tutorials, and we will talk more about polymerizations and the impacts of the use of plastics, which are basically addition polymer from alkene, in the next tutorial. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected.